So, as I was introduced, my name is Srinivasan. I'm a founder and CTO of Aerospike. It's my pleasure to be here today. And what I'd like to do is take you through the fundamentals of why Aerospike exists and how we can, it can be used in AI-related workloads, especially those which are real-time. But first, I want to explain to you the history behind this particular T-shirt that we are all wearing in Aerospike. As you can see, it talks about a dragon and slaying dragons and so on. This came to us from a very early deployment of Aerospike. It was over about 10 years ago. This company called App11, which is a really great company, which is probably handles some of the highest level of workloads related to the internet. And you can look it up. And when we started Aerospike, we were building a system for handling very high throughput, low latency applications. And App11 was basically a poster child. They were growing like crazy in the early days. They're still growing, actually, after 10 plus years. And one of the things that they were doing was they were using what I would call as an inefficient database. It could have been any database. The CTO's name is John Kristnak. And we were speaking about this whole deployment. And what he was talking about was a deployment he had used. He'd used Cassandra, but it could have been any other database in those days. And he said that as the load went up in his data center, because of their growth was explosive, and there are a lot of spikes in terms of, we're talking millions of reads and writes a second on large amounts of data, typically, tens of terabytes of data, even in those days. Today, it is more like 100 to 1,000, like a petabyte of data. But the main thing is, he would say that the database would wake up and it would breathe fire in the data center because it's going to use all the resources and then need more. Because that's what real-time applications demand. I myself have been part of that earlier in a way, at Yahoo. But John was experiencing this, and he called it the dragon in his data center. So they did that POC, they tested Aerospike. I'm going to talk about why Aerospike matters. It matters in these kinds of use cases, extremely high performance at scale use cases, and this is what this was. And then they switched over to Aerospike. Essentially what happened was, with the previous installation that they had, as the load would go up, the resource utilization would go up almost at the same level or higher in their data center. So the number of machines they were using was going from like tens to hundreds to 1,000 machines or whatever. And then they switched over to Aerospike, and essentially this is what he called the dragon, basically, because it's uncontrollable. And then essentially, this is something which he had not seen before. It started coming down with Aerospike. The resources he used. Eventually, it stabilized. So that's kind of the key, okay? The key is, what does slaying the dragon mean here is basically the dragon, in this case, we of course took some poetic license and call it inefficient databases, but it's really you're taming the heavy workloads demanded by online applications. This is because everybody in the world has a mobile phone now, and we are all using things, and more apps get on board, and we use it even more during the day. What this means is enormous loads are generated on these back-end systems. As many of you know, you can't really have a high-performance, personalized application without having a high-performance database as the back-end. And that's basically the problem we have solved. And so that's where this whole slaying the dragon metaphor comes from. You can stop by our booth and get one of these T-shirts if you wish, if you're inclined. So let me get into the talk. Why Aerospike for AI and ML? First, let's look at basically the mission critical use cases that we power already. Now, think about, I already talked about App11, right? We're basically, they're supporting a lot of requests a day across billions of devices and with real-time decisions under 1 millisecond, okay? And that's the kind of workload which created the dragon in the data center analogy I mentioned earlier. Now, PayPal has also been an early user of Aerospike for over, I mean, all of these are over a decade old usages, okay? So, and they've been growing typically 10x or even 100x. So in these kinds of applications, there's a lot of ML-based inferencing. You can call it classical AI, before Gen AI took off a few years ago, and now we are into agentic AI. The classical AI is ML inferencing. What people do is they run a bunch of models. They generate models by training on a lot of user data and application data, and this requires a lot of processing, and then you generate these models. And typically, these generations are not done using a database like Aerospike. It's not really real time at that level. But then, once you generate these models, decisions have to be made in real time. An example is the PayPal decision, where in the presence of a transaction, you need to figure out a fraud score before the transaction completes. Typically, it's about 200 milliseconds to generate a fraud score and less than half a second to complete the transaction. If you don't generate, if a fraud score cannot be generated in that time frame, then the transaction goes through and there is a certain exposure to the business because you have approved a transaction without an accurate fraud score. And that's essentially the problem that Aerospike solved for them at scale. Again, they had a previous database system they were using for it, which was the Dragon, I guess, which Slade. This was a relational database with a cache in front of it, and that was replaced by Aerospike. Aerospike is fast enough that it doesn't need a cache. I'll go into that technology in a second. The other most important thing, and this is something we have said since the beginning of this project, which was almost like 15 years ago. If you want to build a system which is at that scale of what a Google or a Meta or some of these large companies handle, but you don't want to spend the kind of money that they're spending on it by using DRAM, we have technology, which I will talk about, which leverages SSDs, which will reduce your total cost of ownership, not by a little, by about 4 to 5 times. And that's essentially the reason many of these people use us. Like Fidelity uses us they replace other databases like Redis. Wayfair replaced Cassandra, much like AppLovin, But the point is, why do they need to do that? Because if you can use more data in real time to make better decisions, and it still costs less, you can handle more load, your business can grow, your technology is no longer the limiting factor to your business growth. And that's something really important, in terms of ownership. And I'll talk about the technology which makes that happen. Finally, right, optimizing all of this in machine learning and AI. There are many applications that Aerospike has deployed today which don't use machine learning and AI. But the most important ones use them, like the recommendation engines, fraud detection, various other risk analysis. All of this happens in real time. There was a use case I was speaking to a gentleman yesterday where they are approving loans in 15 to 30 seconds for small and medium businesses. And if you want to do things like that, you need to do a lot of analysis, which used to take days, in previous situations, or even hours. You have to do it in seconds. And if you have to do all of that work in seconds, because you cannot actually miss doing the work, you just have to process the data and make those decisions at a faster pace. And that's kind of where business is going. And that's where I think we can help in terms of optimizing for machine learning and AI. And we will go through that use case in a little bit in this talk. First, the next 3 slides are fairly technical. We have written a lot of papers in database conferences and such, which we can share with you if you want to know more details. So I'm going to make a lot of claims here. We have backed them up with real data and real presentations to the leaders in the database field. And we're happy to share all of that. You can even search and find them in VLDB conferences and so on. But we're happy to share it with you. So fundamentally, Aerospike is a shared nothing database cluster. What that means is every node in Aerospike is identical, and you can just simply keep adding nodes. There is no single point of failure, which means there are no hotspots. And essentially, everything is dynamic. You can add nodes, remove nodes. It's elastic, if you will, in a cloud sense. Because if you're not that, you can't actually be a database which supports the kinds of workloads I talked about earlier without any downtime. See, that's the key. You can support workloads at very high throughput, but you need to have no downtime at all, because many of these are mission critical, and also you're answerable to people like the government in many cases, because you can't have your mobile service go down, people can't make 911 calls, okay? It's just not allowed. So there are a lot of important reasons why these high performance workloads need to be always on. The other thing is, there's a lot of, this is a little bit intricate, but there is, when you're running a database, failures can happen, nodes can go in and out. Now, when nodes go in and out, you need to rebalance the data across the remaining nodes of the cluster, so you have the same level of replication factor, so you have resilience. That is a huge effort to move lots of data back and forth, while you are still handling very heavy read and write throughput in the system, run by millions of, typically hundreds of millions of people are using the system, or even apps on behalf of users are using the system. So there's a lot of load on the system, and you're now moving data around. How do you do all that in real time is actually a hard problem, because that's how you keep the system up. And we do a lot of that. And let's say you have a cluster which we are doing all this stuff to keep up, but then the entire cluster is taken out. Maybe a whole data center went out, or a whole region went out in a cloud provider. Then you have active replications, which are to clusters which are farther away geographically. So you could have one right here, in Atlanta, another one in San Francisco, and so on. But that, gives you more resilience. So we support all of that. So essentially, this is a full-fledged distributed database which can do partitioning. I'm not going to go into the partitioning algorithms, but the one thing I will say about them is we can maintain uniform partition balance, as uniform load balancing across all nodes of the cluster, no matter what happens. And there's a whole bunch of algorithms which go into it, which I won't go into it here, but you can read up on it with papers and documents we have. And the most interesting thing I said earlier was we can do all of these things at high scale. Virtually everybody can do things at high scale, okay? But what does it cost? This is the one key differentiation if you take away from this talk. We can do all of the high scale systems, but we can do it at much lower in terms of the cost of ownership. Why is that? Because we leverage certain hardware which other people don't. We leverage it in a different way, and we leverage basically SSDs. SSDs are typically, is it okay?
Sorry, I just dropped my bottle.
Oh, okay, cool. He's safe. Everything is fine. Thank you. So when SSDs are about 10 times cheaper per bit. I haven't done the math recently, but they're super cheap compared to DRAM. So what Aerospike does is we have what is called a hybrid memory architecture. We store the index purely in DRAM and all the data on SSDs. A traditional database, which is shown on the right, essentially brings all of the data into a buffer pool to read it. So it is only as good as the size of the buffer pool. And this is exactly what caused the whole dragon analogy, because when John Krishnak and his team were running the system on Cassandra, the only way to provide, Cassandra is a great database, by the way. I'm not trying to say anything bad about it. It scales amazingly well, but it is not built for high performance. So when you're trying to run a high performance system on a system, application or system which is not designed for high performance, what you end up doing is putting all of the data, indexes, everything in DRAM. So it's a humongous system. Okay, it'll be 1,000 nodes of whatever system that you use. And then what happens then is when you increase load, a lot of failures can happen, and all the real-time prioritization I talked about in terms of trying to move data around and so on, all of this is a huge tax on the system, which makes it behave like the dragon I talked about. With Aerospike, because we have compressed the amount of data that actually can, not compressed, we have expanded the amount of data that can be stored in a single node, because in memory, you can probably store a terabyte of data in a single node. With SSDs, you could, today, we can store maybe 50 to 100 terabytes easily with maybe a terabyte of DRAM. What this means is you have reduced cluster sizes from 1,000 nodes fitting all the data in memory to maybe 50 nodes fitting, with this hybrid memory architecture. So you have smaller cluster nodes. But then I won't talk about this, but now that we have put all of this data, we had to rewrite the code quite a bit in terms of the file system and so on to make this architecture work. But what we can get, take it from me, that we can get sub-millisecond reads and writes. We can do very high throughput reads and writes on the same system. So you can read the latest data no matter what the rate of writes are. And that's actually really important. So you can actually run this. And then there's the whole continuous non-disruptive defrag, I call it, but it's basically back-end processing. We have a lot of headroom. And how do we get that headroom? I don't have the slide in here for that, but let me talk for a minute on that. So we have now compressed the cluster sizes by putting more data per node. But we spent a lot of time optimizing the in-memory paths for transaction. Our system is written in C. It's used as multi-threading. We use NUMA pinning. We use thread affinity. Every trick which you can basically use with modern processor architectures, networking architectures, parallelism. All of that means we can push a lot more transactions per second per node. So you have a lot more data per node. Let's say you reduce the number of the cluster nodes from 1,000 to 50. Now you need to be able to do 20 times more transactions per node because you put 20 times the data in one node. And we do all of that with a lot of optimizations we've done in the in-memory processing. So the combination of this is what creates this system which can handle very high throughput reads, very high throughput writes in the same system, and provide the consistency that you need in terms of reading the latest data that's been changed immediately. And this is really important for a recommendation system, a fraud detection system, because you are always keeping up with what's going on. New fraud techniques are immediately analyzed, and I'll relate all of this to AI in a minute. So, and this is the result of it, okay? So what you have is a system which is basically running, I'm not going to say which is, I think this was a Cassandra-based system, but it had, reasonable response times, right? Under 10 millisecond response time, but look at the variance that is there. Whereas when they switched over to Aerospike, this is a real production deployment which happened 10 years ago. You see how, all of the response times on Aerospike became sub-millisecond, and it's got less variance. And that's fundamentally, it's predictable performance, reduced tail latencies, increased ability to deliver a better customer experience in real time. So that's what this enables, all of this enables you to do. And it enables you to do it at scale. And the TCO algorithm, right? It doesn't even matter which system you compare ourselves with, because everything in memory versus everything in hybrid memory. That's really the comparison here. So you can see the number of nodes in the first case has reduced from 40 to 6, 450 to 60 in the second case, and the third one is 3,000 to 720. This is real, okay? Whole data centers were shut down by the last customer, Criteo, because they could just eliminate several thousand nodes. And that's really important in terms of handling these things predictably and so on. Okay. Okay, now let's talk about AI. Okay, this is the second part of the talk. So far I've talked about the differentiation of Aerospike. Now I'll talk about how it can be applied to AI. Now, predictive AI is essentially what Aerospike has been used by many customers for over 12 years, 13, maybe for the last 15 years, I would say, in many ways. Over the last 5 years, predictive AI is very simple. It's a little bit inflexible and static. So as I mentioned earlier, you generate these models, and then what you're doing with the models is you're applying them in real time. But you can't actually change anything in real time. You have to rerun your analysis and generate a new model, move it over to the real-time system, and then you're then able to get better, that's a cycle going on here. You're constantly generating new models. It takes a few hours. You move it to the edge. You apply them. So a new fraud detection algorithm will be generated. It'll be fed into a new model, and then essentially they'll start getting applied. It's still pretty flexible, but it's compared to what Gen AI and agentic do, it is super inflexible. Okay, so that's the way to think about it. So with generative AI, of course, everybody now uses this. You have open-ended outputs from a single foundation model. Okay. So you are able to provide prompts, and the key is to prevent the hallucination, as it's called, by providing the right set of documents to it. So that's where a database can help, and the real-time aspects of it are really important. So you don't want a decision based on some old data. Agentic is just the newest way of doing it, and here you are actually separating out even further from the end user to the task. Because you provide goals to agents, which can work with other agents. So what you've done is a same user can provide many tasks to many agents at the same time. So your scale has gone up. Already the scale has gone up quite a bit from where we were with predictive AI, because where people arrive at websites and then you're doing stuff for them. And then you go to Gen AI where people are not coming directly to you. And now we're going like people are just dispatching agents. So you have orders of magnitude of usage which is increased. And if it is all going to use real-time data, then the load on the system is going to go by 10x or 100x, even more than what I'm talking about. Okay? So that's the future, basically. So let's take one by one, right? For predictive AI, what you have is basically a basic system where you can, if you don't have enough time, you can just use the rules-based kind of model. But then what you really want is to generate some intermediate risk models on top of it, using the data that you get from a feature store, which is really important, because that's something, capturing behavior as it changes. It's not like static behavior, right? My behavior today may be different when I'm doing some shopping on the internet than it was yesterday, depending on what my needs are. It could change every day, it could change every week. I could go back to something from last month because something is a long-term purchase. So all of that behavior is captured in the feature store, and then based on the existing actions, you can figure that out. And then you can generate some kind of risk model on it. But then eventually, you can even be even further in terms of contextual models. That's how recommendations come in. So you want a great recommendation, for an e-commerce site, you will end up with the cart size, as they call it, the amount of things that a user buys will become more. So, and that will not become more because of any trick they're playing. It is just that they're learning what the user is really interested in and providing it to them at the right time. And that means the user is actually getting a better user experience. They would have already bought it anyway, but now they buy it from this retailer because they were good enough to figure it out from all the information that they have. And that's kind of the decision that's made. Now, in order to make that decision, there is a lot of things that has to happen in a fixed time SLA. That's really important. Pick whatever use case you are. Somebody's asked for something. Buy me a ticket, or in this case, I'm basically going to a website. Let's say Wayfair, and essentially I'm just looking at it. What does Wayfair have to do? It has to actually look at some data, which is basically related to what I might have been doing earlier, what my behavior is right now. They have all these databases and feature stores, as I pointed out. They have to look at it. They get some data out of this. Then they run a few steps, like I pointed out earlier, the rules-based step, the intermediate risk step, and the deep contextual step. If you take a normal database, which is not something like as hypercharged as Aerospike, you might have time to get a few data items, maybe 10 data items, and then you run some rules-based things, and then you get another 15 or 20 items, and then you basically run the intermediate risk step, and you might run out of your SLA. Think of the SLA as 50 milliseconds, for example, which is not unreasonable. It could be 100, but typically 50 is a good number. Okay? Now, if you had a system like Aerospike, where we can get you more data because of the parallelism and the speed at which we can fetch it, you can potentially get hundreds of items and run a rules-based step. Why can you do that? Because you're getting 100 items, but you're using way less time to get them within the 50 millisecond SLA. So in 10 milliseconds, you can get like 1,000 items, let's say. Okay? Now, you get more time to process it. And then you get more steps you can run. You can run a rules-based step, intermediate risk step, and deep contextual step. In between each of that, you can go to an Aerospike database, a feature store, and get more data. So what have you done? You actually looked at more data. You spent more time processing it. So you end up with maybe 5 times the amount of data, 4 times the amount of processing power. You end up with a 3 to 4x better decision. And that is how you win this race with the customer's experience, right? And that's kind of what all of this enables in the predictive AI model. And these are some real use cases. Fidelity has been using us as a cache, as a real-time data store, and they use it with other databases just to make sure that, you don't think Aerospike is a solution for everything. We are not. We are basically help with real-time processing, where there is an SLA, and there is typically a consumer who has something they want to do, and that is what we can accelerate for you. In this case, we can use Aerospike for the low latency, queries. We can cache the query results, even with things like Snowflake in the background. It could be many other databases like that. And Aerospike can also be used as a real-time data store for ingestion. That's one thing Aerospike is good at. We can absorb really fast rates of incoming data because our write rates are really good based on the SSD implementation that we have that I talked about earlier. So the end result is, this is one kind of use case. Then moving on, and I won't go into a lot of these predictive AI use cases because they are the majority of our deployments right now because it's been going on for like 10 to 12 years. Gen AI, I'm going to take you through where something like Aerospike can help. Gen AI, as I said, is a lot more rich in terms of the kind of problems it can solve and how it can solve them based on user prompts. But the biggest advantage of using something like Aerospike is to feed it into a RAG pipeline with real-time data, which is extremely relevant for the particular prompt that is being used. Okay, and that's kind of the key. What is going, you can understand what is going on, and you can feed data. And there are multiple places where you can do this. One is the context itself. If this conversation is going on over maybe a couple of days, then the context of what the user has been doing so far can be fed into the LLM at every time. And we are talking about hundreds of millions of users, okay? So you need to be able to keep a lot of data. You need to be able to retrieve it when the user comes back online again. And that's actually itself takes some level of effort. It is not super hard, given what Aerospike is known to do, but it is important because it's the scale part. It is the speed and the scale part. Both of them are important. That's when we can really make a difference. And then the other thing is you can actually fetch data, and this could be from a feature store, it could be from just documents that you need to run recommendations and so on, that you can fetch it from Aerospike. In addition, we have things like Snowflake and other databases in data warehouse, which we can use. It could also be Databricks, but there are many other systems you can use and feed it all into the RAG. And where Aerospike would help is the real-time aspect of data, where data changes a lot, and you want to get the latest value. And that's the ingestion part and the real-time part. So we can feed all of that into it, so you can now have better decisions come out of the Gen AI pipeline. Here's an actual example of Myntra. It is an e-commerce fashion kind of website in e-commerce company in India. And what they do is they kind of merge the Gen AI prompts. You can basically, here's somebody who's trying to buy a dress for a special occasion, and then she's going to go through this prompt, tell them like, this is what I want, and again, based on what she likes in this case, they are able to merge the prompts, the contexts that are going on. This conversation doesn't have to happen in one go. It can happen over a period of time. People don't have enough time, they're on mobile devices, they may have, waiting for a train or whatever, they just do a few things, and then they get into a meeting, and then they come back and they continue it, right? So you're able to keep this whole thing going in a very sensible way. The end result is you can combine the recommendation engine I talked about based on prior knowledge of this customer, based on what's happening with the Gen AI prompts in this particular session. You can combine all of that to provide basically a set of results, potentially leading to a purchase and satisfaction for this user. Okay, and this is a real use case on Gen AI. Moving on to agentic, the final part of the talk. Agentic is fairly new, and it is evolving really, really fast. I'm not going to go into the details of agentic because there are a lot of security implications, agents working with agents, who monitors them, and there's a whole bunch of activity going on in this area, okay? I encourage all of you to kind of become, to follow this at least. And where something like Aerospike can use, because the main thing about agentic AI is we have just increased the scale by another order of magnitude. Because I could potentially be trying to buy tickets for a trip, I could provide 2 agents completely separate instructions to say, find it this way or find it that way. And they could both be doing it for me. I may only pick one of those items, right? Which means you just increase the scale. So everybody is not doing one piece of work at a time. They're doing maybe 5 to 10 pieces of work at a time. And then these agents have to work with each other. They have to work with real-time data. Because otherwise, if you can't actually do anything, which is, in fact, says I'm actually focused a lot on real-time stuff. So anything in real time requires accurate data. Things can change, schedules can change. Shows can get full, and you don't get tickets. You don't get the tickets that you want. You might have to go to a different time. All of that has to happen, in real time, which means the data has to be fed into the agents, and that is essentially what basically has to happen. So then, and that's just one aspect of it, is you have to get real-time data into it. But an agent needs to be able to look at a lot of different inputs. That's what we do naturally, right? When we are going to go look for things, we ask somebody, a friend. We go to Google and now ChatGPT or whatever. We search and then we look at all of this and we make a decision. And the agent is going to do all of this, but then it also needs real-time data, as I pointed out. That's fairly straightforward. But more importantly, the agent is creating new pieces of data. Now, we usually note it down on a piece of paper, we put it in a notepad or whatever, and then we go back and forth to it. But the agent would need to do that. And these micro databases, as we call them, is actually a great application for something like Aerospike, because we can create data in large numbers in real time and be able to retrieve them really fast. So that is something which is also a good place for something like Aerospike to be used. Now, I don't have an actual use case for this because it's fairly new, but this is something we are working to figure out what the ROI is of these agents. And we can see a few places, but we are continuing to work with customers. And I'm really interested in any thoughts people have on this, as this area is evolving really, really fast. So I don't have a real use case on it, but we hope to have it within the next 6 months or so. So I'll wrap up with what exactly Aerospike is. I talked a lot about the ideas of Aerospike. The fundamental idea is that we run anywhere, okay? We run on any of the clouds. I mean, we have to, right? I mean, cloud is everywhere. So our customers run in their own data centers. They don't run any of the public clouds. It could be basically Amazon, Google, Azure, OCI. It doesn't matter to us, and it doesn't matter to them really, because each one picks a different one. Some customers pick multiple clouds. We're across cloud and so on. We have various clients. I didn't talk about it, but our clients are intelligent. Part of the reason we get our performance is we can offload the server and basically make sure that we can get linear scale. This whole business of the dragon in the data center, the reason Aerospike can slay those dragons is because we can scale linearly without using too many resources. And this is the efficiency of implementation counts, both on the storage side, on the CPU side, on the networking side, and also on leveraging the client application and the servers in an equal way. And then we have a whole bunch of real-time things. I only talked about hybrid memory architecture, which is one specific, I would say, the most interesting thing that we have done. It's a patented architecture and all that, but we also have a potential to provide many, many other choices. You don't have to use memory at all. You could store the index itself in Flash. You will pay for it in some performance, but what I mean is we have choice. As depending on the kinds of workloads, then there is a lot of choice which people can have in terms of deployment. And then you have real-time data services. I talked quite a bit about like moving data around while you're running transactions. And then we support various data models like key value, document, and graph data models. Graph especially is really, really important for many of these AI workloads, especially fraud detection and so on. So, and then we interoperate with pretty much everything else out there in the system. You can read that. I think that is pretty much the end of my talk. What do we do? We do have, what do we call this? At the Studio Theater at 11:15 a.m., we'll be showing a couple of demos. One is how do you discover fraud in real time? And also, how do graphs elevate fraud detection? Hope to see you there. Stop by our booth. It's 118 if you want to get the Dragon t-shirt. They're going fast, so get there early. So anyway, thank you so much for your time. Yeah, I don't know if you have time for questions, but I'll leave it to the organizers to decide that. Oh, there you are. Okay. Sorry.
Talk a little bit about deployment in all the clouds. Can you talk a little bit more? Is it available as a managed service by any of the cloud providers, or can it deploy it as a?
Yeah, we have multiple deployment studies. Okay, the question was, do we have a managed service and what other kinds of deployment options that we have? When we started the company, we didn't have those things, a long time ago. So many of our early customers deployed it themselves. We call it self-managed. Maybe about 8 or 9 years ago, we added a managed service, which Aerospike provides, where we manage a service of Aerospike on a customer's VPC. It runs on all the clouds. You can run it on Azure, you can run it on AWS, you can run it on Google. We do it on all three big ones. We don't need to do it on OCI. And then we have in preview what we call the Aerospike cloud product. As you know, there are three of them: self-managed, which you run it yourself. There is ACMS, the ACM, we call it the Aerospike Cloud Managed Service. We manage it in your VPC. And then there is the Aerospike Cloud, which is running on our VPC. And this is now available as preview in AWS, and we plan to migrate it to other clouds. So we are looking for people to try it out on Aerospike Cloud, and you're welcome to do the other two also. But mostly the Aerospike Cloud might be a good vehicle for people to start now, because then we manage the whole thing ourselves. And then there are issues with some companies don't like to have it in other people's VPCs, then we can talk about what deployments you'd like to have. Okay. Any other questions? Okay.
What are the downsides? So I use this for real time. Obviously, it's not replacing my relational database system of records. Right? So when do I not use Aerospike?
Okay. The question is, this doesn't replace relational databases, and the question is, when do we not use Aerospike? So before I answer that, let me explain a little bit more about what you can do with Aerospike, and then I will tell you when you don't use it. There are some use cases where Aerospike is better by an order of magnitude than others. I think I talked a lot about it today. I won't go into that again. So there, I think typically our competition is really nobody. Even though people may be using something else, we can easily replace it. That's easy. Then there are use cases which also require high throughput and low latency, but also require strong consistency. Distributed transactions, ACID transactions, and so on. We have all of that, but it's only we don't have SQL. The key thing that Aerospike doesn't support natively is SQL. You can still run some SQL queries on it using Trino, Presto, and all that, but I'm not going to count that as SQL support. SQL support is native support for SQL we don't have, but we have native support for ACID transactions. So you can have strictly serializable ACID transactions in Aerospike running across geographically distributed, a cluster which is geographically distributed, and so on. We also have the ability to do geo-distribution, which means you can have eventual consistency also, if you wish that to be an option. We can have strong consistency, like strict serializability, or eventual. So you have the full gamut of all of that. Now, when will you not use Aerospike? When something like Oracle, MySQL, Mongo work really well, and they are not really trying to solve the problems I'm talking about today for consumer-oriented, high throughput, low latency. They do low latency, but it may not be as high throughput, or it may even be high throughput and low latency like Redis, but it's not for large scale. Then you have a lot of choices, okay? So there are cases where Redis will work really well forever. If that is the case, why would you switch, right? I mean, I'm asking it as somebody who has actually deployed systems which work in production before Aerospike. You know, I used to work at Yahoo, we ran a lot of mobile systems. But whenever you get the high throughput, low latency, and scale, the performance, scale, and consistency, you want that kind of combination, that's when you use Aerospike. When you just want basically a lot of features, like relational features, you know, where MySQL, Oracle, Postgres is actually very popular these days, you should use those. You know, I'm actually a database guy from before. I've worked on relational databases too. So they're all good systems, okay? You got to figure out that the reason, if you want to wonder why it is that Aerospike exists, it exists because of the internet and what the consumers are doing on the internet and why database is so critical to it at such high transaction rates. If you don't want to compromise using some other system and trying to work around it yourself, that's what people do. It's not like the other databases don't work. Redis, you would have to do all the distribution work yourself. Cassandra, you would have to put a cache in front of it. We don't have to do any of that with Aerospike. We can just use it, and then you worry about your applications. That's the big, huge differentiation right there. And you will see that in our customers. They're all like really top companies in every vertical that we have. They have the biggest workloads, and that's kind of what we're looking for also, in terms of helping people like that be a lot more efficient and have a better business. Okay, thank you.